In the organization of this project, we have master ambience, dialogue, music, and sound effects buses all connected to a master bus. Each subset of the masters have their own folders of more specific buses, some having aux buses primarily for effects like reverb that can be used for sidechaining. The dialogue and music buses take priority in the mix, sending their output to an RTPC to reduce the volume and low end of the ambience and sound effects buses. For our player, we allow the physical body to determine attenuation and the camera to determine spatialization. The following is how sidechaining works between the dialogue and ambience and sound effects sounds.
Welcome to Jacob Lack's first demo reel using Unreal Engine 5 and Wwise.
For player footsteps, we have running and walking blend containers, each with a switch container connected to all the switches for basic sounds as well as complex sounds if we want to add another layer. There is a subtle RTPC to direct the left and right footsteps accordingly in the mix. As we line trace from the player to the surface, we pick up a physical material where we can then change the basic and complex switches according to the surface. Then we determine if the player is running or not. Here's what that looks like. For the vehicle, each tire will emit sound relative to the listener. Each tire can emit a hitting the surface and bonking into an object sound. An RTPC value is connected to each blend container of those sounds as well as the tires moving on the surface sound. The listener changes depending on the front or back camera, and the RTPC values for the car and tires are checked by the vehicle's velocity. We also line trace from the vehicle to see if the surface sound should play or not with states. The following RTPCs are updated with a little bit of math to determine how much time each tire is in the air, as well as how fast the tires hit an object. Here's what that looks like. For the environment, we have many attenuations that mess with mainly volume, low-pass filter, spread, and focus. Sounds that the player is not close enough to are sent to virtual sounds to maintain performance. We use blueprints of audio splines like bridge creaking and river sounds to follow the player. We have the same thing happening in the cave level along with our reverb zones and portals that connect each one for each size of the space. Many obstacles in the game have an AK component attached to them along with other events that emit once triggered. Running through foliage also uses a blend container with an RTPC value affected by the player's velocity. We check to see if the player is overlapping or not through states, as well as making sure the sound only plays if the player is overlapping and not standing still. Check out the playthrough to see the full game, and thanks for watching.